Hello, Tam. So I just want to talk through your coast topic and the quiz and give you some feedback on the quiz that you did. Um, in general, things were done very well and you've done a really good job with the end of this topic. We are going to cover certainly a good amount of it again next year. We are going to have plenty of time to do that, but a lot of you have put yourselves in a really good place from the lessons and the quality of work that you produce from those lessons. Just to go through a couple of the questions. First thing, the first question asks about erosional versus depositional landforms. Now, first of all, landforms is a really important word, and it means something that you can see because something that you can see on the coastline, and if it's erosional, then it has been created by the wearing away of the coast. It's been created by destructive waves, by high energy conditions, and that's all of the stuff that we did before lockdown. In terms of positional things, looking at things that have been created by very low energy conditions, constructive waves, and it is about things being dropped and deposited on the coastline. So you're looking at beaches and sand dunes and spits. Okay. Now, by a long way, the most difficult positional landform is a spit, and we will go through a complete formation without a shadow of a doubt next year. But just to go through the key bits of the sequence, the first thing is that all sediment is always being moved along the coast by longshore drift. Okay, those kind of triangles, right-angled triangles, moved along the coastline in right-angled triangles, and it's always moving in the direction of the prevailing wind. Now, prevailing just means common, most common wind direction. Okay, now you get spits at a point where you reach a bend in the coastline because longshore drift can't keep transporting sediment along the coastline because it would have to go in a different direction, and it can't because it has to follow the prevailing wind. So longshore drift starts to push the sediment out to sea. Okay, imagine that none of this is here yet. This is just water, so it pushes it out to sea. And all of that sediment builds up and builds up until it pops above the water. And you have a little tiny extension to the coastline. You have a little tiny spit. Now the spit can get longer and longer as longshore drift can move the sediment along it and put it in deeper water. But the next key bit of the sequence is, why does the end of the spit keep bending? Now this is called a recurved end, and it bends because of the secondary wind. Now prevailing wind is the most common, secondary is the second most common wind direction, and it quite simply blows the end of the spit inland, and that's why you get these bent ends, these recurved ends. Now, the last thing about a spit is it stops growing, and that is because spits grow over the mouths, the openings of rivers, and the closer to the middle of a river you get, the stronger the current is. So, as longshore drift is trying to deposit sediment on the end of the spit like normal, now because the current of the river is so strong, it just gets washed away, washed out to sea, never builds up, so your spit stops growing. It's never going to reach land again. Okay. Now, behind a spit, in this area here, because the spit blocks out all of the waves and the high energy conditions from the sea, it's always really very calm in this area. And calm conditions leads to deposition of tiny, tiny things like mud, okay, tiniest sediment. And the mud builds up, plant grow in it, and that's how you get your salt marshes. And you nearly always see a salt marsh formed behind a spit, okay? That definitely was the most difficult lesson and bit of the final assessment as well. Formation of a spit, really difficult GCSE question. We will practice it again next year though. Just worth mentioning, spit, extension to the coastline, but it never rejoins land. A bar is exactly the same, okay? It's an extension to the coastline, but it will rejoin land. That's the key difference. And the reason it does that is because as your spit starts to extend, there's the bend in the coastline again, extends out into the sea, but this time it's not extending over a river, it's extending over a bay. So there's no strong current to stop the spit getting longer and longer until it rejoins land. As soon as it's rejoined land, it's called a bar. Okay. Very quickly, in terms of coastal management, some people were a little bit weaker with this within their quizzes. A couple of things that were commonly misinterpreted. Hard engineering sea defences. They are things that are made out of non-natural materials, but non-natural to the coastline. So, for example, groins are made out of wood commonly, and wood is obviously a natural material, but it is not something you don't find trees slack bang on the coast. Yeah, they're something you find inland. They're not natural to the coastline. Wood is not natural to the coastline. So groins sit in the hard engineering category. Okay. Soft engineering, these are things that are natural to the coastline. So all of these things are made out of sand or pebbles, things that you would naturally find sat on the coast. Okay. In terms of the most likely big question on all of these sea defences, you need to know in relation to all of them, which is the most expensive, which is the cheapest, which is the one that's going to last the longest, which won't, which is the one that is nicest to look at and best tourism, which is the one that's probably most ugly and might put people off, which is the one that's going to be a best habitat for animals and won't be. Any kind of longer answer question, that's what they're going to be picking up on. You're understanding, right, seawall, it's really, really effective at protecting the coastline. However, it's extremely expensive, so lots of people can't afford to build one. Okay. And last bit, if you get a question that wants a specific case study, wants you to name an example of a coastal management strategy, all of these are coastal management strategies, but this is your case study, okay? And it is a coastal realignment strategy, okay? We looked and you had a lesson on Medmary, Sussex, and again, we'll probably go over this, but very quickly next year. And coastal realignment is allowing the sea to flood inland. It's accepting, right, sea level is rising, we are going to lose some land, and it's controlling what we do lose, okay? So what they do is they get rid of any sea defences and they let an area of land that they don't mind losing flood. Now, it's nearly always farmland. And you think, well, actually, farmland, it can be useful. We're a growing population, we need food, but it's nearly always fairly unproductive because it's right next to the sea, so it's very salty. It can be flooded every so often, so it's generally poor quality farmland. So you don't make much money from it. So what they do is they allow the sea to flood inland onto that farmland, and it will naturally create a salt marsh. And as the waves try to fight their way through all of the salt marsh plants, the energy of the waves is going to be absorbed. Now, all of the waves are going to slow down and slow down, so you're protecting the coastline. The salt marsh naturally does that. Now, if you have a particularly bad storm, this village here, something that you don't want to flood, you've got a last line of defense, and that's what they'll always build around the area that they manage the flooding on. Okay, and that's the last line of defense. It means that the flooding won't go any further than we want it to. Puts a rock armour in front of this embankment. It's called earth bund, but it's basically an earth embankment, and the rock armour will protect the embankment from the waves so they don't crash up against it and destroy it really quickly. Okay. Now, coastal realignment is really good. It's very effective. It improves the environment because a salt marsh is better environmentally than farmland. It attracts lots of tourists, so you can make lots of money from it, arguably more than you would from the farmland. The main problem with it really is it is a very expensive technique. Okay, just building the embankment around the edge, installing the rock armor, destroying the sea defense, and sometimes you need help this salt marsh to flood. To form using by dumping lots and lots of mud. It's all extremely expensive, and 28 million is up towards the top end of some of our coastal management strategies. Okay, so that's coastal realignment. And again, we will cover it next year, but hopefully that just gives you a little bit of information and feedback on some of the things that you assessed on that last quiz.